Hello. Let's start yet another vlog and continue Ziglings. Yesterday I reached to exercise number 67. Yeah, 66 we solved. Let's pick it up from there. Comptime number 2. We've seen that Zig implicitly performs some evaluations at compile time. But sometimes you'll want to explicitly request compile time evaluation. For that, we have a new keyword, comptime. This ASCII art is beautiful. When placed before a variable declaration, comptime guarantees that every usage of that variable will be performed at compile time. As a simple example, compare these two statements. var bar 5, there is error, comptime var bar 25. Okay, the first one gives us an error because Zig assumes mutable identifier declared with var. This will be used at runtime and we have not assigned a runtime type of trying to use a comptime int of undetermined size at runtime is a memory crime and you are under arrest. The second one is okay because we've told Zig that bar2 is a compile time variable. Zig will help us ensure this is true and let us know if we make a mistake. What is the error I'm getting here? This is the crime that is happening. And what is happening is, in this contrived example, we decided to allocate some arrays using a variable count, but something is missing. This is defined as comptime int, and we are increasing it. Okay, and it should be the other way around. Comptime, yeah, it's like this. Zig build. Okay, this is result. Built-in bonus. The compileLog built-in is like a print statement that only operates at compile time. The compiler treats compileLog calls as errors, so you'll want to use them temporarily to debug compile time logs. Try uncommenting this line and play around with it. Copy it, move it to see what it does. Okay. Zig run exercise 067. Found compile log statement. It's an error. Compile log output. Count at time. Referenced by inlined. Okay, and then here let's remove it and print it here. So now I get the value, and then I have the type as well as comptime int. Ah, okay. This message is not anything relevant, right? I can even remove this. Yeah, exactly. So whatever is inside it, we get its type and its value on that point in time in the program. That's why, and it gets as many arguments that I want, right? Sorcery. Yes. Okay. This is interesting. And it only works with comptime values? No, I don't think so, right? Actually, let's do var name and put it grocery. Variable sorcery is never mutated. Name sorcerer. Ziglings I wanted to do. For the name now I get a runtime value. Interesting. So only the values that are known in compilation time will be shown here. Good. And now I want to comment it out. Click run. It executes. Good. Let's do 68 too. Comptime 3. Okay, let's mark them here as well. So 67 done. You can also put comptime before a function parameter to enforce that the argument passed to the function must be known at compile time. We've actually been using a function like this the entire time. Okay, fn print, yeah, this one we learned, right? In the exercise and calculator, I required to take one value, the format value at comp time, otherwise it was nagging that print statement can use it. Of course, back there we weren't using print. It was not this std debug print. It was the print from std out struct. Notice that the format string parameter fmt is marked as comp time. One of the neat benefits of this is that the format string can be checked for errors at compile time rather than crashing at runtime. The actual formatting is done by stdfmt format, and it contains a complete format string parser that runs entirely at compile time. Okay, std debug print. This struct is the model of a model boat. We can transform it to any scale we would like. 1.2 is half size, 132 is 32 times smaller than the real thing, and so forth. We did something neat here. What is the neat thing? First, let's build it. Okay, consider using const. Local variable is never mutated. Okay, we did something neat here. We've anticipated the possibility of accidentally attempting to create a scale of 1 rather than having this result in a divide by 0 error at runtime. We've turned this into a compile error. This is probably the correct solution most of the time, but our model program is very casual, and we just wanted to do what I mean and keep working. Please change this so that it sets a 0 scale to 1 instead. Yeah, the disappointing part is that I cannot even compile this to see if this happens, but probably I can do that, right? If I do my scale equal to 0, unable to get my comptime. Okay, there are a few things happening here. So let's first fix this, right? And we take it from there. If my scale is equal to 0, my scale is equal to 1. This is the logic I want here, right? And then we are setting this. Okay. The error remains the same. Pub and main. Whale shark. Hey, we can't just pass this runtime variable as an argument to the scale me method. What would let us do that? If I do comptime, yeah, I should have done comptime here. This is because the method up here expects it to be passed in comptime. Oops. Yeah, I'm not going to fix this. It becomes 0 and up there I'm fixing that. Going deeper. What would happen if you did attempt to build a model in the scale of 1 to 0? You are already done. You would suffer a mental divide by 0 error. you would construct a singularity and destroy the planet. And how about a model in the scale of 0 to 1? You're already done. You'd arrange nothing carefully into the form of the original nothing, but infinitely larger. You would construct a singularity and destroy the planet. Answer can be found on the back of the Ziglings packaging. I don't know what does that mean, but here, let's see. Divide by 0. This is happening, right? This is happening, and up there we are checking. And there is a divide by 0 error inside Zig that it raises when we do that in compile time. Because we are running it in compile time, right? Let's remove this for a second. Run exercise 068. Division by 0 here is called legal behavior, yes. So this is that, and then another thing that I have is, what if the other side is 0? Yeah, other side is 1. This is hard coded, right? But for real, what if I do print and do this, and here do 0 by 1? Oh yes. 0 by 1. Why this print is not printing anything? Ah, okay. I made a mess. That's why. But when I do 0, is, yeah, returning 0. That's fine. Okay, that's the answer to the second question then. And number 68 also solved. 69. One of the more common use cases of a comptime function parameter is passing a type to a function. In fact, types are only available at compile time, so the comptime keyword is required here. Please take a moment to put on the wizard hat, which has been provided for you. We are about to use this ability to implement a generic function. Yeah, this is what I did for calculator's print statement. Right? And then we have this const makeSequence u8. This function is pretty wild because it executes at runtime and is part of the final compiled program. The function is compiled with unchanging data sizes and type. and yet it also allows for different sizes and types. This seems paradoxical. How could both things be true? To accomplish this, the Z compiler actually generates a separate copy of the function for every size type combination. So in this case, the three different functions will be generated for you, each with machine code that handles that specific data size and type. Please fix this function so that the size parameter is guaranteed to be known at compile time. Okay. Oh no, yes. Count time sets the size of array of type T, which is the sequence we are creating and returning. Oh no, I want a new build. Yeah, this was easy. Comptime 5. Number 70. Being able to pass types to functions at compile time lets us generate code that works with mutable types, but it doesn't help us pass values of different types to a function. For that, we have the anytype placeholder, which tells Zig to infer the actual type of a parameter at compile time. Then we can use built-ins such as typeof, typeinfo, typename, hasDecl, and hasField to determine more about the type that has been passed in. All of this logic will be performed entirely at compile time. Let's define three structs: duck, rubber duck, and duct. Notice that duck and rubber duck both contain battle and quack methods declared in their namespace, also known as decls. Okay, there is duck, and then there are two functions. Two decls. Okay, and then rubber duck also has listen. Isn't the developer talk about programming problems? Silently contemplate problem, meet helpful sound. Okay. And duct connect. If self diameter equal to other diameter, connect. Duct error, unmatched diameter, and where is duct error defined? Down here. Okay. Pop-up and main. What is the error? Okay, there is a question mark we need to fill in. Pop-up and main. This is a real duck. This is not a real duck, but it has quack and vowel. Robert, I think. So this is still a duck. Yeah, if it walks like a dog and makes sound like a dog, then it's a duck. This is not even remotely a duck. Is duck? Okay. Okay. Now we want to have a function to check the type of parameter passed to it, and yeah, basically return a boolean out of it. This function has a single parameter which is inferred at compile time. It uses built-ins type of and hasDecl to perform duck typing. Yeah, to determine if the type is a duck. We'll use hasDeclaration to determine if the type has everything needed to be a duck. In this example, hasIncrement will be true if type 2 has an increment method. Please make sure my type has both val and quote methods. So hasDecl, the compile time type would be possible duck, and the method is a string, and what I need to check is paddle and hasDecl possible duck quack. isDuck. We'll also call the quack method here to prove that Zig allows us to perform duck actions on anything sufficiently duck-like. Because all of the checking and inferences we perform at compile time, we will still have complete type safety. Attempting to call the quack method on a struct that doesn't have it, like duck, would result a compile time error, not a runtime panic. Okay. Okay, what's happening here? White says the possible duck should be known. Unused local. Okay, this I'm going to error. Must be comptime known. Unable to resolve comptime value. We are doing anytype here, right? And according to this up here, we'll tell Zig to infer the actual type of the parameter on compile time. So this is the benefit of compile time. Oh, the error is online. No, under 26 is this, right? Should I specifically call these comptime? No, this is already is redundant, yeah. Let's wrap the like this. Does it even make sense? No. Interesting. Unable to resolve comptime value. Types must be compile time known, and that's what I expect it to do. The error is in the body here. Okay, let's ask Claude. What I want is GPTel. Go here. Why the following function doesn't compile and unable to resolve comptime value possible. And then here to see the error occurs hasDecl expects a type, not a value. Ah, okay. That's why. Okay, that was embarrassing. So here, as a possible duck, I should say my type. Yeah. Okay. And what is the error here? Ah, nothing. So that's the thing here for has declaration. Yeah, it says it should be the type. I was passing the value itself, and here I'm not passing the type to the function, but the value itself. That's why I can call it down here. Okay, learned something. Cool. I think that's it for today. We reached number 17. I managed to round up the numbers again. Yeah, thank you for watching. Please feel free to leave comments. Let me know what you think, what I missed, what I need to learn. I would really appreciate it, and see you later.